Okay, today we're going to be solving exponential equations. This is section 7.6 of our chapter 7 notes found on page 9. An exponential equation is an equation in which the variable appears in the exponent. To solve an exponential equation, first thing you're going to express both sides of the equation as powers of the same base. Note, if the bases are unequal, you bring the larger base down to a power of a smaller base. Sometimes only one base needs to be changed, but sometimes both bases will need to be changed to powers of smaller bases. Second, you would use the power rule of exponents, meaning you multiply exponents and don't forget to distribute. Third, apply the principle that if x to the a equals x to the b, then a equals b, i.e. equate the exponents. And fourth, solve the resulting equation from step 3. So if we look at number 1, we have solve for x. 4 to the x squared plus 4x equals 4 to the negative 3. You have both sides of an equation in which the bases are the same. The bases are 4. Right? So the bases are the same. So if 4 to the x squared plus 4x equals 4 to the negative 3, that means the exponents must be equal. So we equate the exponents. X squared plus 4x equals negative 3. We have an equation. In this case, it's quadratic, so we want to solve for x. Write it in standard form, add 3 to both sides, and we get x squared plus 4x plus 3 equals 0. Now continue solving the quadratic equation. Lead coefficients 1, go to the constant. What are the factors of 3 that add to 4? Right, 3 and 1. So this factors into x plus 3 times x plus 1 equals 0. Set each factor equal to 0. We usually skip this step and go right to the solution, but I'll write it this time. Subtract 3, so x equals negative 3, and subtract 1, x equals negative 1. So there are two values of x, negative 3 and negative 1. Number 2, we have 2 to the x plus 1 equals 16. Again, we need to express, back to 1 here, we need to express both sides of the equation as powers of the same base. Right? We don't have same bases here. We have a base of 2 and a base of 16. So we bring the larger base down to a smaller. So in other words, 16 can be expressed as 2 to what power? 16 is equivalent to 2 to the 4th. So replace 16 with 2 to the 4th. Let's just copy down the left-hand side, 2 to the x plus 1. So we have 2 to the x plus 1 equals 2 to the 4th now. Same bases, equate the exponents. So x plus 1 must equal 4. Subtract 1 from both sides, x equals 3. Check it. does 2 to the replacing x with 3. 3 plus 1 equals 16. 3 plus 1 is 4. 2 to the 4th is 16. Number 3. We have 4 to the 3x equals 8 to the x plus 1. We have two different bases. We need to express them as powers of the same base. Take the larger 8. Can 8 be expressed as 4 to a power? No, so bring it down to something even smaller. 8 can be expressed as 2 to a power. So replace 8 with its equivalent, 2 to the 3rd power. So all I'm doing here is I'm taking 8 and expressing it as 2 to the 3rd, right? 2 to the 3rd is the same as 8. Let me copy the exponent, x plus 1. And now on the left-hand side, we want to express the base 4 as 2 to a power. And 4 can be expressed as 2 squared. And copy its exponent, 3x. Now, we have 2 squared raised to the 3x equals 2 to the 3rd raised to the x plus 1. So we have a power raised to a power. Rule is you multiply those powers. So I have 2 to the 6x equals, we have a power raised to a power, so we're multiplying, and make sure you distribute. So that's going to be 3 times x plus 1 is 3x plus 3. So that's 2 to the 3x plus 3. So now both sides of our equation are powers of the same base, 2. So we equate the exponents. So 6x equals 3x plus 3. Solving this for x, this is nice, it's linear, it's not quadratic, so we just subtract 3x from both sides. Six x minus 3x is 3x. 3x equals 3, and divide by 3, x equals 1. Let's check this one. So substituting 1 in for x. So 4 to the 3 times 1, does that equal 8 to the 1 plus 1? Well, 3 times 1 is 3, so 4 to the 3rd is 64. And 1 plus 1 is 2. 8 squared is 64. Yes, 64 equals 64. Number 4. 9 to the x plus 1 equals 27 to the x. We need to express these with the same base. Always go down to a smaller base. Take the larger 27. Can we express 27 as 9 to a power? No. What can we express it as? We can express it as 3 to the 3rd. So replacing 27 with what it's equivalent to, 3 to the 3rd is equivalent to 27. So we have 3 to the 3rd raised to the x. Now express 9 as a power of 3. 9 is 3 to the 2nd. So I have 3 squared raised to the x plus 1. power to a power, we're going to multiply. We're multiplying these. So make sure you distribute the 2. So that will leave us with 3. 2 times x is 2x. 2 times 1 is 2. So 3 to the 2x plus 2 equals, multiply 3 times x is 3x. 3 to the 3x. We have our same bases, so equate the exponents. So 2x plus 2 equals 3x. Subtract 2x from both sides, and x equals 2. Number 5. Here we have 1/2 to the x equals 8 to the 2 minus x. We certainly can't express 8 as 1/2 to a power. A fraction. Let's try to get rid of that fraction. 1/2 can be expressed as 2 to what power? 1/2 can be expressed as 2 to the -1, right? 2 to the -1 would be equivalent to 1/2. Okay. Let me copy my exponent x. Now take 8 and express it using a smaller base. 8 can be expressed as, use the same base we used here, 2. 2 to the 3rd. So replacing 8 with 2 to the 3rd, copy the exponent, 2 minus x. Again, we have a power to a power, so we're multiplying those exponents there. And the same here. Power to a power, you multiply the exponents. And make sure you distribute the 3. So 2 to the -x equals 2 to the 3 times 2 is 6. And 3 times -x is -3x. Same bases, equate the exponents. -x equals 6 minus 3x. I'll add 3x to both sides. Solving this equation, get 2x equals 6. Divide by 2, x equals 3. We'll check this one. Substituting 3 in for x. One half raised to the 3rd. Does that equal 8 raised to the 2 minus 3? Okay, that's 1/2 cubed, which is 2 cubed is 8, so that's going to be 1/8. And 8 to the 2 minus 3, 2 minus 3 is -1, and 8 to the -1 is also 1/8. So 1/8 does equal 1/8, so that checks. Number 6. 1/4 to the x equals 8 to the 1 minus x. We need these bases to be the same. I cannot express, or we cannot express 8 as 4 to a power, so bring it down to something even lower, 2. 8, we saw, was 2 cubed. Copy my exponent. So now for 1/4, well, 4 is 2 squared, and to express it 1/4 as 2 to the power, we would have to write it as 2 to the -2 power, raised to the x. Multiply 2 to the -2x equals, make sure you distribute, 2 to the 3 minus 3x. Equate the exponents. -2x equals 3 minus 3x. Adding 3x to both sides. X equals 3. I'm checking this, and you're certainly welcome to use the calculator at times to check. 1/4 raised to the third, does that equal 8 raised to the 1 minus 3? Well, 1/4, I distribute, 1 to the third is 1, 4 to the third is 64, so that's 1/64. 1 minus 3 is -2, and 8 to the -2 would be expressed as 1/8 to the +2, or 1/8 squared, which is 64. So 1/64 equals 1/64.